Let us try to solve the exercise number 8 in the part A of data structure lab. In this exercise, we are supposed to create a program to implement a dynamic array, and then we are supposed to find the smallest and largest element in this array. So we are supposed to create a array, and then we are supposed to put an element into there and find the smallest and the largest. So let's go ahead and let's build this exercise. I'm going to go to the code block here. I will click on the file new and I'm going to open a new file. I will select the C and C++ source file. Let me click on the go and let me select the C as my program, and let me go to the next one and store the or save this file at the proper location. And we are supposed to find the dynamic array, and I'm going to just say dynamic, that's all. So you can give any name to the program, but see to it that you don't put spaces in between the name. So let's put this one, and that's end of it. As usual, we need a stdio.h because we have to input something from the keyboard, so we need that particular thing. So let me start with the direct with the main function. So I have this void main, and we are supposed to create an array. So we will dynamically get the allocation for the array in the memory, and we will use a pointer that will point to this particular allocation. So how do we do that thing? I will create a pointer here. Let me call this pointer as a. Generally we use the array name as a, so I'm going to use that thing. And because it is an array, you know very well, we need a for loop to read the element and find the largest and the smallest. So I need a counter variable. Also, an array contains n number of elements, so you need the value of n. And we have asked to find the smallest and the largest. So I'm going to use the two variable minimum and maximum to indicate the smallest and the largest element. So let us first start with the n here. As usual, whenever you have the array, first you ask what is the total number of elements. So I'm going to use the same thing over here, and I'm going to say enter total number of elements. There is the e gone elements. Okay, so that's it. Okay. And I'm going to read the value of en. For reading, I'm going to use the scanf function, and I'm going to use the %d, and I'm going to read the value of en. Now I'm going to get the memory allocation for n here. And how do you get the memory allocation for n element? You know very well, you have this malloc function. So let's go with the malloc function. And we have to get the allocation for because it's an integer array. We have to get the allocation for integer. How do we get the integer allocation? We are going to say size of integers. Now it is not one integer. If you just run this one, you are going to get the allocation for one integer. But I don't want for one integer. I want for n integer allocations for n integers. So how can I get the n integer? I'm going to multiply it with the n. So what is this n? Whatever the user has input. If the user say as n is equal to 5, so it is 5 times the size of the integer. So this is what you're going to get it. And I'm going to store it in the whatever allocation I'm going to get it. So this n number of allocation, I will make this pointer point to this particular allocation. So this pointer a, I'm going to point to that. How do I do that? I'm going to say this pointer a is equal to that. So a is going to point to the allocation. So this is going to give me the allocations for n integer values. So that is an integer allocation that will be stored over here. However, you know very well, malloc always returns a void pointer. So I will make this one as an integer pointer. So that is simple as that. So I will make it point to an integer. That's the end of it. So you got the allocation for that, and then let's go ahead. Sometime what you get is you get an error here. If I get the error, I will fix that. Otherwise, let me continue. If I get, I will fix it. So let's see. Let me keep my finger crossed. Suppose if for some reason allocation is not given, for some reason you are not able to get the allocation. In that case, A will have a null pointer. So if A is equal to null, that means you are not able to get the allocation. In that case, I'm going to use the printf, and I'm going to say to the user that there was the error, okay, and I'm going to say could not allocate memory. So that's enough. Okay, so could not allocate the memory. If such a thing happens, so for some good reason, if it is not able to allocate, then this is going to happen. Otherwise, we are done with it. So we got the allocation. So I'm going to use the printf statement, and I'm going to say enter values. So let me put it in enter n number of values or n elements into array. That is, I think that will be a good word here, array. So that is good, where n is the total. So if n is equal to 5, how is it going to look like? Enter 5 elements into the elements. Let's make elements into the array. How do you read the 5 elements? You have the for loop here. So for I is equal to 0, what is this I? I already have declared here. So I is equal to 0. I less than n, so you know very well how to use this for loop now. So then we are going to use the scanf function, and we will read the integer values %d into the array. So how do you read the array? Remember, it's a pointer, and I'm going to use the pointer plus the value of I. So when I is equal to 0, so I is equal to 0, it will point to the first allocation. When I is equal to 1, it's going to point to the second allocation, third allocation, and so on and so forth. So this is what it's going to do. Now, this is done with the reading of the element. What to do with the remaining part of the program? Remaining part of the program, now whatever elements that are entered, so this is a simple story. So whatever elements are entered, let me assume that the first element, I don't know what is the first element, let me assume that the first element itself is the smallest, as well as first element itself is the largest. So I assume that the first element is both smallest and largest. So how do I write that in the program? So I assume that the maximum and minimum E is same as A of 0. It is not A of this A of 0. You know very well, in an array, just to look at this array, the first element is A of 0. Then you compare it with the remaining elements. So suppose if you say A of 0 is 5. So I assume that the minimum element, minimum value is 5, and the maximum value is 5. Now what to do? Compare it with the next element. Suppose if the next element is 7. What do I mean by saying next element? So the A of 1, let me compare it with the A of 1. So if A of 1 is greater than the maximum, what is the maximum? Is 5. If A of 1 is greater than maximum, then I'm going to say that my assumption is wrong. 5 is not the maximum. 7 is the maximum. Compare it with the next element. So if the next element is 10, then I'm going to compare it with the A of 2, and I'm going to say if A of 2 is greater than the maximum element, which is currently 7, then I'm going to say my assumption is wrong. 7 is not the maximum. The new maximum is 10. Similarly, I'm going to do it with all the elements, okay, until I reach the end of the array. When I reach the end of the array, whichever is the maximum will be stored here. In the same way, I'm going to start comparing with the minimum element. So first I assume that A of 0 is the minimum. I compare it with the next element. If it is less than the minimum, then new minimum is this. Now 7 is not less than 5, so I won't do anything. 10 is not less than 5. So let's assume that the next element is, that is A of 3. A of 3 is 3. So now you notice that the minimum is 5 here. My assumption is minimum is 5, but there is one element 3 which is less than my assumption. So what I'm going to say, my assumption is wrong. Let 3 be the new minimum element. In the same way, I start comparing it with all the remaining element until I reach the end of the array. If I find any element which is minimum than the assumed value here, then I'm going to change it and say that my assumption 3 is not minimum. There is one new element which is less than 3, and that itself is the minimum. So this is what I'm going to do. So we will start with the for loop. So I'm going to start with the for loop. For I is equal to 1, because 0th element is already taken up. Okay, so I'm going to start with the I equal to 1. I less than n, I plus plus. So I'm going to take that one. And what is our assumption? Our assumption is the same. If a of I, if you find that there is one element which is greater than my assumed element, that is my assumed element is maximum, then what you are going to do is you are going to say that no, my maximum is my assumption is wrong. Let the new maximum be a of I. In similarly, we'll just use Control C and Control V. If you find that there is a element which is less than my assumed minimum, then I'm going to say that no, my assumption is wrong. So there is a, let this be a new minimum. You do this till the end of the for loop. Once a for loop is completed, you just go out and you print and you say that smallest element SM, smallest element is this. I'm going to use percentage D, and let me say, if you want to slash n, let it be there, slash n. Okay, let it be there. Okay, largest is okay, largest is this element percentage D, and what is the smallest? Smallest is minimum, and largest is our assumption is maximum. So that is the end of it. So let's try to run this program and see whether you get the minimum and maximum. You can just save it and let's run it. Okay, so if there is an error, let's see what is the error. Okay, I put so sometime if you get like this and you don't know what is going on, go to the view and go to the logs, and you will find that I have not put the semicolon here. I will put the semicolon. If there is any error, let's fix that errors. That is syntax error, and then we will run it. So the function is where is this? What is this? Okay, there is one comma missing here. Okay, so let me fix that one. And let me run it. I think everything is proper. Let me assume that 5 elements are there in the array. I'm going to say 10, 5, 20, minus 5, minus say 2, and 4. Let's say okay, 1, 2, 3, 4, 5. So the smallest element, you notice that the smallest element is 2, and we are getting the smallest element. And the largest element is 20, and we are getting the largest element as 20. So that's it in this small exercise. Thank you for your interest. We will meet again in the other exercise. Thank you.